Okay, hi guys, welcome back. So today I'm gonna try to implement a face recognition system using one-shot learning approach. If you are not familiar with what one-shot learning is, please go back to, I have a video specially just trying to explain what is one-shot learning approach is. But basically the idea, it's called one-shot learning. The idea is in the normal deep learning approach, you need tons of data to train your model, right? In a one-shot learning approach, you just need uh, one time of training um, the model. So it's very supposed to be cost friendly. It's very supposed to be also fast, effective, uh, but it has also a specific use case. So in this we are trying to solve the problem of face recognition system or face verification. The difference between face verification and face recognition is face verification is one-to-one, meaning if you happen to know, for example, the use case would be you're comparing one specific pictures to one to another one of different picture, or it could be the same pictures. It could be, for example, for if you are going to the airport and if you before you enter the immigration or before you enter, sorry, the boarding, or before you enter the place where they scan you, you have to show your ID, and they could use a face verification system. So it will you can show your driver license or passport with your photo, and they will sort of like have a sensor. It will scan your photo, and it, based on that, they will compare it to the database available uh, um, um, uh, based on the photo, and then they will let you in based on your photo or not, right? Um, wait, is that face verification? And face recognition is one to many, so they were comparing it to your photo and to many people. I think that's the face recognition. So it knows who you are. Face verification is just to verify that you are you. So I'm trying to think. So in the airport, sorry, in the airport case, that would be the use case for face recognition, because your face, the system wants to know. My name is Danny Iskandar, so the system wants to know it's me, Danny Iskandar. It's not like Simon, or it's not Thomas, or it's not Susie, right? It wants to know me specifically. That's Danny Iskandar. So it has to recognize my face, right? So it's comparing me, my photo, or my face in that sense, to, I don't know, 300 million of the U.S. citizen, right? Because I happen to live in the U.S. for passport purpose, right? To enter, let's say the airport space where you go through the immigration system, right? So that's face recognition. But face verification is just to verify the use case, to verify that you are who you are. Uh, you're that sorry, who you are that you are trying to prove. Okay, let me say that's not the right word to say it. So for example, if I an ID or a passport, for example, the use case would be if you want to enter, for example, office, right? If you let's say you work for Google, right? Or I work for Google or Facebook or whatever, like Office X, right? So in this system for the office, um, and you want to enter, let's say make it smaller. You just want to enter, let's say a specific, for example, exclusive, let's say membership inside the office. I'll say, or you can say like LA Fitness or whatever. So uh, it 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 um so the system already knows that you are Danny, right? For some reason, and then you just have to prove that uh, you are holding um, or how do you say it? You are holding the ID necessary to enter. For example, it's an exclusive membership for LA Fitness or for Amazon Prime member. For example, if you want to go to Amazon Go, right? So identifier system already knows what you are, so it will locate your pictures because it already knows who you are, right? Um, so it will get your pictures inside the system of the this face verification AI system. It gets your pictures, so it's one, right? One, and then it will compare it to your ID when you flash your ID, or it will flash even your face, right? Oh, so you're just comparing one to one, and it will verify. Oh, yeah, that face is actually the same or not the same. So if that face is the same, then it will just let you enter. So I think the use case is more for like a membership kind of uh, thing that it already knows that you are in the system, you know, and then so it recognizes you are you. It just want to know if you are eligible for that membership, right? But for face recognition, it's not for membership. I mean, you're a member of the U.S. citizen, right? Among the one out of the 300 million people, right? But you just want to enter the system, but you don't have you you're not an like it's not that you pay monthly to become a member to enter that airport, right? You already pay the press ticket, of course, but it's just the system wants to know that you are you are that person. So it's kind of tricky. The difference is for I got also like confused. But anyway, so that's kind of for the use case. Right now we're trying to use the face recognition to solve um, um, and use it to for okay. So we can just like go through this really quickly. Okay, so this is taken from the Coursera, which I've been taking on and off, kind of. So there's two kind of face recognition problems, right? One is first verification is which is basically asking, is this the claim person? For example, at some airport, you can pass through custom by letting a system scan your passport and then verifying that you, the person that carrying your passport, are the correct person. A mobile phone that unlocks your face is also using face verification. It's a one-to-one matching problem. Face recognition is more answering the question of who is this person. For example, the video lecture shows a face recognition system by the employee entering the office without needing to otherwise identify themselves. Right. So the system is like um, face recognition is more like uh, um, it's like the system it behaves like a person. It knows like who you are. Like if I'm meeting my friend, oh I know that's Thomas. Oh I know that's Susan. Right. But face verification I think is more like kind of narrow the use case, or is more like a limited, a very a narrow kind of intelligence. It's because it's only answering the question of is this the claim person, right? So if probably if you kind of won a lottery, right, um, and then you want to claim the lottery, right, and then you go to the to the counter to claim the lottery. The person at the counter doesn't really care who are you, right? If you're the president of the United States, or if you're even a crook, or even if you're an engineer, it doesn't, they don't care, right? What it matters is you hold that card, right? And then you present that card, and then the person, okay, so you got a card. That means you are, and then probably the card also says that you are. It's for like your name, under your name, and then it will just ask you another card, which is your ID, right? Once they got the ID, I got a good example. For example, if I want to go to the post office to claim a shipped goods to me, and which just so happens that it's being shipped to the post office instead of to me, right? And this is using just a person, right? So I go to the post office, I got the stub that is already being um, uh, uh, into my house, like because I was like away, so I bring that stub, I present it to the people. So pretend the people is a face verification system, right? So I present the people. So the person nodded, okay, you got the stuff. That means you have there is something goods that is meant to be uh, picked up, but that person still wants to know that you are Danny, right? So you and the person doesn't know what I look like, right? The person just care if I show them an ID. So I show my driver license or passport. Okay, this is me. This is the proof that I'm Danny. So, and that's it. The person doesn't have to know who I am, right? The person has just to know, is this the claim person? So in that sense, okay. So that's not clear. It's a one-to-one matching problem. Okay. So Facenet learns a neural network that encodes a face image in the factor of 128 numbers. So basically, if you have a 36 by 36, for example, a pixel of image, right? Or you show your face and then be digitized into a 36 by 36, right? Or times 3 because it's color. And after going through, normally it's using a ConvNet, convolution neural network. After going through a several um, kind of black boxes, inside the ConvNet, the like going through one iteration and then you max pull it, and then another iteration you max pull it, and then another iteration, and then at the end of the output would be 128 numbers of vector, a row of kind of column factor, 128 numbers. So it's already being encoded, being translated. So the FaceNet will basically extract all of those features that are kind of relevant for that particular face, right? So, and you're just comparing this, the idea is basically just to compare the two factors. And then if it's kind of the same or similar, or the difference is like small, a certain lambda, you call it, or certain alpha, then you can determine if two pictures are of the same person, right? Um, so how do you compare the two factors? In this case, we are using an objective function or a loss function that has to be minimized, and it's called a triplet loss function, right? You can basically do it like the easy way, kind of like you just subtract from. So you have one factor is the anchor factor, which is the face that you want to compare um, from, and then the other factor is the factor that comes from the face that you want to compare with, right? And then you just do a subtraction. That will be the easiest one. But we want to be there's a probably, I think, a more advanced function. Triple lot, it's called triple because it has three components, which is the anchor, which is the base image that you want to compare from, and then the negative, which is the face or the pictures of a negative image, means uh, a person that are not supposed to be there, that are not supposed to be verified, that are not supposed to be recognized. That's why it's called negative. And then the third photos, which is it's called positive, which is the photos that are um, supposed to be matched with the photo that are going to compare from. Yeah. So that's why it's called positive, which is the person supposed to be there, or um, is the person is supposed to be the claim. The person is what the person claimed to be. Okay. Okay. So that's why it's called triple loss. So you kind of like comparing it between these three photos. So I think first you kind of like you subtract from the anchor, the base picture, to the negative, and then you also subtract between the anchor and the positive pictures, right? And then you kind of like see the difference between the two. Yeah, do some like kind of like a absolute, put the absolute. I kind of forget the exact algorithm for that, but you get the idea, right? Why it's called a triple loss function. So you want to minimize that because once you trying to that because that's the objective function. Once you try to minimize that, um, and then you know whether that person is supposed to be there or not, or the person is the right person, or the person is supposed to be the claimed person, right? Um, okay, and then we use this encoding to perform face verification and face recognition. Okay, so in this exercise, this is using Python with Keras. In this exercise, we be using a pre-trained model which represent ConvNet activations. So it's a pre-trained model using a convolution network, using a channel first convention as opposed to the channel last convention used in lecture and previous programming assignment. In other words, I'm not sure what is using channel first and opposed to channel last. In other words, a batch of images will be shipped as so it has four components instead of N hits and W and C. Okay. Both of these conventions have a reasonable amount of traction among open source implementation. There isn't a uniform standard yet within the deep learning. Okay. I think the NH and W is refers to the H is height and then W is the weight. And C, I'm not sure. What is this? The channel probably? And then this M is like the numbering system within the image. Okay, so we have to load now the required packages. So you're importing the sequential library, conference, 2D, zero padding, activation, input, concatenate, model, um, batch normalization, max pooling 2D again, average pooling, concatenate, lambda, flatten, dense, initializer, import layer, Keras import backend, set image data format channel first. It's just the format here. Okay. Import CV2, as NumPy. Okay. Pandas, TensorFlow. Okay. Let's run that one. Takes some time. It's still like an asterisk. Um, okay, done. So using a knife face verification. So this is the database, and then this is the input. You want to compare if they are verified, right? The picture is the claim to be, right? So for example, you show these pictures on the post office to claim your goods, right? And then if it's, oh, okay, it's the same person, okay, then you just give it. You don't have to know whether um, um, the person name is so and so. You don't have to know who is she or who he is, right? So I think one of the indicator is you can show your ID for face verification, but I think for face recognition, you have to show your face, kind of. I do think you can still, maybe you can still show your face, your real face, right? Because it's like what do you call that in an iPhone? There's a face recognition just to open your your phone, right? Instead of putting a passcode or a password, you just show your face and it will recognize it and it's open up your phone. I think that's yeah, it's a face verification, that one. Uh, because it doesn't really know who you are, kind of. It's just who you claim to be. Because inside the database of that iPhone, your iPhone, it only has um, your database image as a reference, right? It doesn't have any other people's database. Yeah, because if there is another people here putting and then just compare it to your database, then it will just reject it, right? But it's not the claim. Uh, a person, right? While, for example, if you go to the airport, for example, it's different because you want to know, like, I think probably more to know who you are, kind of, right? Because it's, yeah, yeah, I think, yeah, because I think it's personal because it's personal, right? It's not meant for public, the use case. Your iPhone is meant for just for you, but I think airport is meant for public use case, right? While getting your goods at the post office is also, well, the post office is for public, but when you're from their point of view, it's just for you, kind of, because you just have to show an ID. They don't really care if you're, I think, yeah, it's not their concern, right? Because like this one, it's not iPhone, yeah, but probably if it has to do with national security, for example, it has to do with public, like airport. If you are the airport, if you are the government, you are concerned about national security, so you want uh, sort of to have a more secure face recognition. So you want to know, have to compare it one to many. You just, it's not enough just to answer the question of who do you claim to be, but it's more crucial to answer also who you are, right? So it has to compare it with one to many. Okay, I think it's clear. Hmm. The use case is very interesting. It's kind of confusing. Okay, so of course this algorithm performs very poorly since the pixel values changes dramatically due to variation in lighting orientation of the person face, even minor changes in head position and so on. You see that rather than using the raw image, you can learn an encoding. So you put the image into a function, right? So that the element-wise comparison of this encoding gives more accurate judgment as to whether two pictures are of the same person. Okay, so that's the purpose of this whole F thing. It's basically the one-shot learning algorithm or the deep learning algorithm. You encode. You can like compare it pixel by pixel element wise. But it's the same because there's a variation in lighting. There's a the orientation of the person face, minor changes in the head position. Uh, if you just do a point-wise variation, then that doesn't work. So the purpose of this F, this function, this deep learning algorithm, or this one-shot learning, basically to extract the main features. This is so incredible about deep learning or um, machine learning algorithm in general because the computer will sort of decide what features matters. It's like it's kind of like the way our brain works, right? When we look at a person face, for example, your friend like Tom, you know, like instantly, okay, Tom is like this. You kind of have a sense. If you met Tom for the second time, you know it's Tom. It's not Bob. It's not your other friend, right? So your brain is like have a really interesting mechanism to extract features, right? So, and that's, I think it's being mimicked into the deep learning. That's why it's called also a neural networks because it's basically mimicking the way our neurons, which is inside our brain, works, extracting the features, though unconsciously, because we are unconscious when we're doing that. We sort of just intuitively know, okay, this is the features of Tom, this is the feature of Susan, this is the feature of David, this is the features of X, right? So the second time you met that person, you intuitively knows, you don't like analyze, okay, it has to be like, the eyes has to be like a bit like this, the nose has to be a bit like that, the skin has to be a bit pale with like a bit brown, a bit, you don't do that. You just intuitively know. That's the magic of our brain, right? Okay, let's move on. So, encoding face images into 128 dimensional factors. So we are using a ConvNet to compute encodings. Um, okay, let's break it to here. We'll see you next video. Thanks for listening.